Hi everyone, and welcome to this video about simplifying surds and the surd rules. So in this video we'll first talk about the rules that we can use for combining surds and surd expressions, and then we'll use those rules in order to simplify more complicated surds. We're going to start off by looking at two very simple ways of simplifying surd expressions, if we have surds that are multiplied or divided by each other. Let's start by looking at the example of root 2 multiplied by root 3. We can always write surds as an index, so in this case, writing 2 as 2 to the power of a half and 3 to the power of a half will enable us to figure out what to do here. As we have both of these numbers to the power of a half, if we remember back to our index rules, it means that we could have been doing this 2 times 3 in the bracket to begin with, and then raising the entire bracket to the power of a half. And if we now convert that back into a surd, we'll see that that's root 2 times 3. So we've gone from two surds being multiplied together to having one surd and the numbers inside being multiplied together. Of course, the answer to this would be root 6. Now this is one way of simplifying a surd expression. You can see we went from something more complicated on the left, where we had two surds and a symbol, to just a single surd on the right. This can also be the case when we have surds being divided by each other. For example, if we had root of 7 divided by root of 14. Of course, we could write these as powers as well, so 7 to the power of a half divided by 14 to the power of a half. Using the same idea as before, I can now bring out the power of a half to the outside of the bracket. I can now replace the power of a half with a surd, so it would be root 7 over 14. So we've already simplified it from two surds to one surd, and now I can go further and simplify the fraction inside the bracket, so that at the end we would end up with the square root of a half. Let's generalize these surd rules using some algebra. So in the case where we have root a multiplied by root b, we would always be able to write that as root a times b, so going from two surds to one surd. Of course, this rule would also work in reverse. So if we had two numbers multiplied together inside one surd, we could always split that up into two. Similarly, if we had root a divided by root b, we could of course turn that into the square root of a over b. Of course, this rule also works in the reverse way. So if we had a surd with two numbers being divided inside the surd, we could split that up into two surds on the top and bottom of a fraction. Now let's use these rules to simplify some surds. I'm going to start off by looking at this example, the square root of 18. Of course, 18 can be split into its factors 2 and 9. And the reason why I'm picking 2 and 9 is because one of those factors is a square number. Let's write that down. So we have 2 multiplied by 9 inside of my surd now, where the 9 is a square number. We'll see in a second why picking a square number is important. Using the rule that we just learned, when there's multiplication inside the surd, I can actually split it up into two surds multiplied together. So now that's root 2 times root 9. And now the importance of the square number becomes apparent, because we have the square root of 9. And of course that is going to be 3. So combining these two numbers now, I would have 3 multiplied by root 2. So going from a complicated surd with 18 inside the root, to now 3 root 2, which is a much simpler and nicer way of writing this number. Of course, in some cases, we can't really simplify the surd anymore. In the case of 35, the only factors that we could split 35 into are 1 and 35, or 5 and 7. Neither of these pairs of factors contain a square number in order to reduce the number inside the surd. No square number means we can't simplify to get a whole number at the end. Let's take a look at the square root of 72. Of course, inside 72, I have the pair of factors 2 and 36. I can now split this up using the rule from before, and with 36 being the square of 6, I can now square root that to get the whole number 6 multiplied by my surd. A couple of things to note. First, we always write a whole number times by a surd in this way, with the whole number first, no symbol between, and the surd afterwards. Another thing that I suggest when you're doing this topic is to memorize some of the square numbers. If you know the square numbers up to around 10 squared, then you're going to find that simplifying and finding factors is a much easier task. When you're looking for that factor that's a square number, remember to look for the biggest one possible. If you can get the biggest square possible inside the surd, it means you won't have to simplify multiple times. Let's take a look at these two examples here. For the first question, we can see that right now we would not be able to add these two surds together. Remember, when we're adding surds, they have to be with the same number inside the root. For example, I could add together 2 root 2 and 3 root 2. However, here we have root 18. Let's see if we can turn root 18 into a simplified surd. What we're going to do is start by looking for a square number that is a factor of 18. That can be found in the form of 9, 9 times 2 being 18. Now I can split this up into root 2 times by root 9. Let's bring down the 2 root 2 in the meantime. We can see that root 9 is going to go to the whole number 3, so we would have 3 root 2 plus 2 root 2. And so now we find we have the same number inside the roots. We can add together how many root 2's we have in total. 3 plus 2, of course, is 5 root 2's in total. Let's look at the example on the right. This, of course, is a division. So let's go back to the rule that we found at the very start of the lesson. We're going to split this surd up into the root of 81 divided by the root of 49. 81 and 49, if you remember your square numbers, will simplify to 9 over 7. We don't have to simplify that fraction any further, and we can leave the answer like that. Let's take a look at this example here. We're asked to turn this 5 root 6 into the square root of a single number, so the form that our answer should take is a square root with a number inside, just like this. No other terms at all. So what we're going to have to do is work backwards through our method and turn this 5 into a surd. Remembering that the square root of 25 is 5, that means I could write 5 like this instead, those being the same. Now I can times by root 6. Let's reverse our rule from before and write these as a multiplication under one root. Finally simplifying this, we would get 150 inside of our square root. So the answer would be root 150. Thank you for watching this video. I'm glad you've made it all the way to the end. If you have any questions about the video, remember you can leave them down in the comment section below. Please like and subscribe if you enjoyed it, and I will see you in the next video.